Okay, here comes problem 30, very similar to the previous problems in the same section. They're both about solving triangles and using the law of the sines to do so. This problem says, problem 30, by the way, it is a sister to problem 33. So problem 30 says that B is equal to 2, C is equal to 3, B is equal to 40 degrees. Yeah, so let's always good to draw a picture here. What we're going to do is solve any triangles that might end up. So I've got, again, a base angle 40. That's equal to that, and that's angle B. Okay. So this is side B over here. Side B is 2. Here is side C. C equals 3. This is equal to 2. So side A is down here. That makes this angle A. And here's angle C over here. So let's remember that the very first thing we have to do is ask the question. I think the way to do this is to ask the question, 1, is B greater than 3? Because if it is, there's only one triangle, and the answer is no. Okay, well, let's go further. Let's calculate H, where H is this dimension right here. And let's do that by saying that 40, the sine of 40 is this length H divided by this length. So the sine of 40 is equal to H all over 3. So 3 sine 40 is equal to H. I've got to calculate that. So there's a 40 degrees. There's a sine of said 40 degrees times 3 is equal to 1.93. So the next question is, what's the relationship between A and B? And you can see, between B and H. And you can see that B equals 2 is greater than H is equal to 1.93. And yet B is not greater than C. Okay, so here's the situation where this side is a little longer than H, and so it can come down here and hit here, or it can hit here. I've got 2 triangles to deal with. 2 triangles. Let's see if we can deal with them now, especially if I can do it in this amount of space. I feel like we ought to change colors here. Let's look at this triangle first, okay? Let's look at this triangle right here first. Okay, what have I got? I've got a sine 40 all over 2 is equal to sine of C all over 3. Yep, sine of 3 all over sine of C all over 3. So notice that C can be this angle or C can be that angle. So let's see what happens when we calculate 3 times sine 40 all over 2. This says sine of C is equal to 3/2 sine 40. Okay, and that number is sine 3 times 2 divide. Okay, that number is 0.96. Okay, so I'm going to go over here, yeah, and I'm going to say, you know what? Here's on the unit circle, 0.96 is right here. So I've got this angle and I've got that angle, right? This angle greater than 90 degrees is this guy. This angle, is probably this guy, and this angle less than 90 degrees is this guy. So let's go find both of these. I'm going to take the arc sine of this guy right here, and I'm going to find that this angle is 74 degrees. Okay. which makes this little angle 16 degrees, which makes this 90 plus 16 degrees, or 106 degrees. So I'm going to actually, let's get a little bit more accurate. This angle is 74.62 degrees, okay? So if I subtract that from 90, or subtract that from 90, this angle is 15.38 degrees, and if I add that to 90, right back, then this angle, this is my first value of angle C. Here's my second value of angle C. Do it like that. It's 105.38. So I've got two triangles, and there's one of them. It's got an A, B, C, and an A, B, C, and then there's a second triangle. I'm never going to be able to jam this all in here. I'm going to try. It's got an A, B, C, and an A, B, C. This first triangle is this guy. They all have C is equal to 3. Or they both have it. They have B is equal to 2. We're going to calculate B. They all have angle B is equal to 40 degrees. 40 degrees. Okay. And what we've just found is angle C, in one case, is 74.6 degrees, and in the other case, it's 105.38 degrees. So now I can make use of the fact that there's 180 degrees in the sum of all of the angles, and I'm going to calculate this A. I can't read my own writing. What is that? 105. 105.38 subtract. This A is 34.62 degrees. This A over here is 140 subtract 74.6 subtract. This one is 65.4. And now I've just got to calculate these two values of A, and the way I'm going to do it is to say that we've already used sine. Let me change colors here so we can keep track. I'm going to use this dark blue to calculate A. And I'm going to say A all over sine A is equal to, what is this, B2 all over sine of B, 40 degrees. And therefore A is going to be equal to the sine of A times 2 all over sine of 40. So what is A? In this case, it's 65.4. I have to take the sine, I have to multiply by 2, and I have to divide by the sine of 40. And I get 2.83. Okay, then I've got to do that again, only this time use this as A. So I've got to go 34.62. What am I doing? I'm taking the sine, I'm multiplying by 2, and I'm dividing by the sine of 40. And that side is 1.77. Okay, so these are a little bit of a pain. But I hope you kind of understood the formalism that we went through. You absolutely have to start here by evaluating the lengths of the sides relative to one another and relative to the hypotenuse. Decide if there's 0, 1, or 2 triangles. And then right now we're using the law of sines for these side angle problems in order to deduce what all the sides and triangles are of the one or two resulting triangles. All right.